BTS in the city. BTS in the city. In the city. Okay, fine. We'll look at what is fun, right? These are fun. This is a fun topic, to be honest. Fun functions, right? So this is an extraction from the 2017 Department of Education. So it's question 5 and question 6. You need to understand that functions, the topic, you're gonna be writing for 30% of that paper. 30%. So it contributes a lot of marks. So without wasting any time, in this question you were given a hyperbola and an exponential function, right? So you are required to determine, okay, let me use this one. You're required to determine f at -3. So I'm just going to substitute -3 in the place of x. So f at -3 is equal to -3 all over -3, which is what I'm substituting, plus 2, and then all plus 1. So this is going to give me a positive one. So my answer is going to be 4. So I have -1 divided by -1. So the answer is 4. Getting to the second question, determine the value of x. Why it's 4, right? So remember something, always know that if they give you something, if it's coordinates always are like this. That's the coordinates. X, then y, right? This still represents y. So my y is equal to 4. So I have in the equation 4 in the place of g of x, right? That's what I substitute. 4, and then I have 2 exponent negative x minus 4, right? So I'm going to have 8 because I'm taking the 4 that side. This is equal to 2 exponent negative x. So I have 2 exponent 3 from the laws of exponents. Therefore, the value of x is going to give me a -3. Right. Now, I want you to remember something. Yeah, but I'll explain it in the questions that follow. So getting to the third question, the asymptotes of f. The asymptotes, we have two. The horizontal asymptote, right? The horizontal, that is where y is going to be equal to this value here, which is 1. Then we have the vertical asymptote, right? So we're going to take this here, then we equate it to 0. So I'm going to say x plus 2 equals 0. Therefore, the vertical asymptote is going to be x is equal to a -2. So always remember this for a hyperbola. If you're dealing with a hyperbola, you have a hyperbola. I did this in the previous video too, so that you remember. Y is equal to a over x plus p plus q, right? So horizontal asymptote, y is equal to a positive q. You take it as it is, but for the vertical asymptote, you need to equate this equation, the denominator. You need to take this thing, then equate it to 0. So it's going to be x plus p equal to 0, which is going to give you a different sign. Okay, so when I continuing here, let's get to the the range of G, 5.4, the range. So if I'm looking for the range G, I need to know at least how is my structure for the exponential function. So I have g of x being equal to 2 exponent negative x minus 4. Now, this is how you get confused, right? So let's break this thing down quickly. Let us say you have, this is for exponential function, right? So y generally for grade 11, y is equals to a b exponent x plus p, then plus q. That's what happens there. Now, the shapes. Let's get to the shapes because with the range, you need to have an idea of the shape. The range is the y values, right? So if b is greater than 1, right? This is something you're gonna have. You're gonna have something like this. You're gonna have something like this. If b is greater than 1, this is the shape, right? And then if b is a fraction, right? This is what you're gonna have, right? Provided, provided that, provided that, provided that a is greater than 0. Because what this thing tells you, it tells us if the graph is a tells us above, the graph is above or below. Below what? The asymptote. So if I have a being greater than 0, the graph is above asymptote. Then if this is when it's positive, then if a is negative, right, then you have a graph below, below. So it's going to be below asymptote, below the asymptote. So this is above the asymptote. That's what you're gonna have, right? So I can have a Cartesian plane like that one, right? Then I'll have an asymptote there. Here also, right? I'll have the asymptote there, right? Or can have it like this, right? Have the asymptote here. It doesn't matter with the x-axis, so we just have to know that it's above the asymptote. So let us say that we have a being less than 0 now. This is basically a reflection, right? So you're gonna have something like this. The graph now is that. Then here it's going to be like this, right? This is below. This is below the asymptote. This is below the asymptote. This is below the asymptote. A tells us if the graph is above or below. This is below the asymptote. Below the asymptote. It's below. You have examples. Example here, we have b, y. Okay, I'll start with this one here. Y is equal to 8 negative, negative, b is greater than 1, 3x plus 5 maybe, right? So a is negative, b is positive. Always remember that the letter that carries the x is b. So y is equal to 2x plus 4. The value of b here, it's 2. This is b. A is going to be the invisible one. That is your a. But the one that carries the exponent it is always b. Good. Now you have an example here where something is a fraction, negative 1 over 3 exponent x. This is how they can confuse you. They can say to you y is equal to negative, then 2 exponent, no, 3 exponent negative x. They would do this thing. It's the same thing as, this thing is the same thing as y is equal to negative 1 over 3 exponent x. You remember laws of exponents. So b is a fraction. Don't get confused here. Don't think it's a whole, it's an integer or a whole number. Okay, good. Now you need to know the shapes. So getting back to that question, let's get back to the question. So this is what you have, right? We need to identify the shape. This is how they try to confuse us. We know this is 1 over 2 exponent x minus 4. The shape of this thing, b, a is above the asymptote, then b is a fraction. This is what I'm going to have. That's something like that. Not the actual thing, but that's the shape. So it means that my range y has to be greater. The curve exists above the asymptote. Y has to be greater than -4. Cannot be equal to, it has to be greater than. It only exists where there's -4. So here will be -4. -4, then the graph will cut the, yeah. Mm, Oh, why am I saying equal sign? Greater. It has to be greater. That's the range. Then let's get to the next question. X-intercepts and y-intercepts of f. This question, a lot of you guys get excited when you get these type of questions because it's easy. But you need to relax. You need to calm down. We know, otherwise you're gonna make mistakes. So I'll start with the y-intercept. Y-intercept, 5.5. Y-intercept, x is equal to 0. So f at x is equal to -3 all over 0 plus 2 plus 1 equal to, gonna have a negative 1 over 2, right? So I have 0 is 2, -1 over 2. That is my y-intercept. Then the x-intercept, y equals 0. So 0 is going to be equal to -3 all over x plus 2 plus 1. Then I do the algebra here. -1 equal to -3 all over x plus 2. So -x minus 2 equal to -3. Therefore, the value of x, when I take that, is going to give me a -1. Right? So I take that it's a -1, so it's going to be a positive 1 actually. So I have 1 is to 0. So I have my intercepts. Okay. And then determine the equation of the axis of symmetry of f, which has a negative gradient. Again, axis of symmetry. I'm going to repeat the same thing I did in the previous one. If they're talking about the axis of symmetry, if they're talking about the axis of symmetry, if they ask you about axis of symmetry of a hyperbola, let's go to the hyperbola. Axis of symmetry. Now there's a language barrier there. Sharp. Y is equal to a over x plus p plus q. One with a positive gradient. You take everything here. You take everything here. That's this axis of symmetry. So for positive gradient, this is what you do. Y is equal to positive x plus p plus q, positive gradient. Then the negative gradient. Y equals negative x plus p plus q. These are the things you need to do. Example, right? The example is the question there. Here's the example here, right? Here's the example. We're gonna take everything here, this one's, right? So y is going to be equal to negative x plus 2 plus 1. So therefore, y is equal to negative x minus 1. That's the final answer when we solve this thing. And then here's the easiest and another easy question. Sketch. Bro, like these examiners get bored sometimes. So you have your x-axis there, you have your y-axis. So I've started with the questions here. When you sketch, it's advisable to begin with um asymptotes, then intercepts, and then you join the points. Asymptotes, intercepts, then join. Don't start with points. It wouldn't make sense. Start with asymptotes. So I have the asymptotes from the previous question, right? So my asymptote x is negative 2 and then y is 1. X is a negative 2, then y is 1. And then the intercept for the exponential, there it is right here. The asymptote, if they ever ask you about the asymptote given the equation, just know that this is q. Q is the asymptote. Q is the asymptote. And then good. So this will be negative 4. That's this point here. And then I have a 1 here. And then followed by intercepts. The x-intercept I have 0 is to 1, right? Here is 0, is 1 is to 0, sorry. So I'm gonna have 1. Here is 1. Then I have also negative half. So this will be negative half here. Good. And then you simply join. And then before, remember with the hyperbola, for sketching the hyperbola, generally, this is what you need to sketch. To sketch, you need these things. You need to know the quads, right? In which quadrants will the arms lie, right? So for example, how are you gonna find that? A is gonna tell you that thing. If A is positive, you have a function like this one. This function is decreasing. Then you have a when A is when A is negative, you have an increasing function. So you know where the arms are if you know A. That is for sketching, right? And then asymptotes, and then intercepts. That's sufficient. That's what you need. Only these three. Only these three. The quads, you look at A. With the asymptotes, you look at what P and what and Q. With intercept, you just equate to 0. That's it. Let's continue to this one now. So I can be able to sketch, right? I know the what's this? In the asymptotes, I've already found the asymptote, so I can sketch F. So negative half and 1, right? I know A is less than 0. Here, negative 3. So it's going to be here and here. So we're gonna draw a curve there. Shouldn't touch the asymptote. It shouldn't touch the asymptote. Then another one here. I know it's a perfect curve. I know. Who am I? Now, this is F. I need to label that this is F. Then we go to G. On G, we already know the y-intercept. No, the asymptote. We need to find the y-intercept. The y-intercept for G. So let me see if I did calculate. Okay, I did not calculate any y-intercept or x-intercept for the exponential. So for expo, before I sketch, I need to know those things. I need to know the shape, right? The shape. The shape is the chord for the hyperbola, right? I need to know the asymptotes. Asymptotes. I need to know the intercepts. That's what I need to sketch also. Same with the hyperbola. So the shape, I know the shape. It's this one. That's number one. Number two, asymptotes. Y is equal to -4. Check the intercepts now. 0 is equal to 2, -x minus 4. So 4 is going to be equal to 2 exponent -x. So I have 2 exponent 2, 2 exponent -x. So x is going to be equal to -2. This point here, that's the x-intercept. Then looking at the y-intercept, x is 0. Y is equals to 2 exponent -0 minus 4. This is not 0. Your excitement will get you saying that the answer here is equal to -4. Your excitement. So you need to calm down when you get questions that are easy. Calm down, analyze, and work through. So here, 2 exponent 0, it's equal to 1. This is equal to 1. So this is going to be equal to 1 minus 4, which gives us -3. So this is the y-intercept, -3. Then I can sketch. Oops, that was close. It almost went to the asymptote. Doesn't touch the asymptote. Must not touch the asymptote. That's -3 there. And then this is G. Get your full 6 marks. Now, get into the final question. Given that f at -1 is equal to f at g at -1, this is a point of intersection. Point of intersection. So let's see the point of intersection. I have one here, then I have another one here where they meet. So it means here, this point here, it's what? -1. I don't know the value of y, but I know the value of x is -1 because they're saying the y value is the same as the y value at g then. So if this is -1 here, it's 1 unit. So it means that also here it's going to be 1 unit. So here I'm going to have what? -3 as an x value. Because this point is from what you call this? The asymptote, right? It's cutting it equally. So now to analyze this question, what they mean here, what do they mean when they say this? Let me show you something. What do they mean? What are they saying? What are they saying to you? Interpretation. 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 What do they mean? They're saying to you, if g of x is greater or equal to f of x, they want a point where g is above or on top. You know what? Like, yeah, on top, under, okay, on top. When it's above or like on top, when someone, like, when something is on top, it means like it's above it, right? That's here. This tells us that it's on top of This one has to be below, right? If they say g of x equal to f of x, they're saying what? Point of intersection. Point of intersection, where the graph cut, like where they meet, right? Or where they pass each other. Like, here's that point. Let's say you have a graph like this and then another one like this. This point here, right? Or let me do this. And then this point here and this point here, right? This is G, this is F. These 2 points, they're saying equal to, that's what they mean, point of intersection. And then when this is above, when it's above, let's look at this graph here. Here's F, the straight line. Right, let me make it more vivid. Here's a straight line. So let's look at where G is above. From here, if you can see something, this space here, G is on top from this point here. This one is a critical point, very important. Because before this point, when we measure going that way, this is it's been on top. After this point, F, it's at the top now, until this point. And then after this point again, F is going to be, okay, G is above, actually. It's always above after this point. So getting back to the question, check. I'm going to look at where G is on top of F. If I look at something, the green one is G. You can see just before -3, G is at the top. So my answer for 5.8, X is less than -3 or equal to. That's when it's above. After -3, it's down, 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 going to 2. And then after this is -1. From -1 going there, G is below, right? G is below from -1 going there. But look at after 3, just after 3, we're not certain, but then in the space here, between 3 and 2, red one is at the top. So let's look at from 2. From 2. From 2. Let me do this just so you can be clear. Let's look from 2. From 2, it's the asymptote. Green is at the top. Can you see that green is at the top? Till 1. Till 1. Then after 1 again, red is on top. After 1, red is on top. So it means again between what? X must be between -2 and 1. And a -1, in fact, -1. I'm saying included because of it's a point, but with -2, it's excluded because of it's an asymptote. It doesn't exist for F. Ba, ba,